here's our problem. This is what we're going to be figuring out, and I'm just going to work through it bit by bit so you will better understand it. And here is the actual problem for A. It's asking us to find the value of f of 0. Okay, in order to find f of 0, we're going to let x and h equal 0. And the problem it gave us in the directions was this, and this is what we're going to use to figure out f of 0. Okay. X. Here we go. Alright, there's that. So because x and h both equal 0, we're just going to plug in 0 for each of them. Therefore, looks like this. And 0 isn't really positive or negative, so we're just going to ignore those two negative signs. Okay, now we have that. Therefore, 0 plus 0, equals 0. So we have f of 0, which is what we're trying to find. This is what we need. So we're part of the way there. And when you add two of the same, you use coefficients. I sometimes get that confused and might square it by accident. Not a smart thing to do, but it happens. Anyway, so then we have this. Looks complicated, but it's really not that bad. So, same concept as if you were dividing 5 by 5, which equals 1, which is this. That's the answer to this problem. It's just same number divided by the same number, and you get 1. Okay, here's B, and here it is asking us to find the f of negative x equals 1 over f of x. Okay, once again, I'm just going to work it out. See if we can figure this out. And then here, I'm just going to write what it's trying to ask us to figure out so I can kind of keep an idea of where I'm supposed to be going with this. Okay, and we're going to use that same equation we used in the first one. Same concept, I think. Or no, maybe not. Okay. Negative h. Alright, there we go. There's that. Alright, and here we're going to let just h equal 0. Alright, now let's plug in all the zeros for h. X plus 0 equals f of... Oops, it's supposed to be a plus sign. My bad. F of 0. Alright, there we go. See, and x plus 0 equals 0, so it's going to be f of x. Or okay, x plus 0 equals x. There we go. Okay, for this, now we are going to finish this. Alright, from A, we figured out that f of 0 equals 1. So, we're going to plug in 1 for all places where it says f of x, or f of 0, I mean, my bad. There we go. Alright. Now, here's where it gets slightly complicated. Anyway, so we want f of negative x over here, because that's what we're trying to find. Oops, I just kind of marked it out. Anyway, so we want to multiply this over, and divide this here. Therefore, it'll look kind of like f of negative x plus 1 equals f of x plus 1 over f of x. Okay, from this point, this part right here, you can put f of x under both of them. What I mean by that is that, gotta carry all this over, is that you can put f of x over f of x and 1 over f of x. See, here's what we needed. So we're almost there. Just gotta figure the rest of this out. And the next part's really not hard. See, and since it's f of x divided by f of x, You can mark that out and put it over, or put 1. So now we have f of negative x plus 1 equals 1 plus 1 over f of x. See, now all we need to do is subtract over a 1 and cancels that out, and now all we have left is what we needed. Now we have all the proof, show that we got that. Okay, on to part C. It's asking us to use part B to figure out this right here. And I don't know if you've been noticing or not, but I already have like the general work down below, but I'm just working it out so I can give a better explanation. Okay, right here, this is what, once again, we're trying to find, and this is the problem we're going to use, which was also given to us. And if you remember from part B, we found sort of the f of the negatives equals 1 over f of x. Okay, with this right here, we can replace the negatives, such as, take that, sorry my hair keeps getting in the way, plus f of h equals 1 over f of x plus 1 over f of h. Okay, for this we can find a common denominator that we have to multiply this by f of h, and we have to multiply this by f of x, meaning that this will take place. Okay, we have then that, what is it, f of h over f of x, f of h, plus f of x over f of x, f of h. Okay, I kind of worked ahead because I messed up and I had to rewrite it. But anyway, here we have this, what I left last time. So, with that, since these have the same denominators, you can add these two, the numerators together, therefore getting this right here, and with that, see, this right here is its own number, so it's therefore technically over 1, and to get a correct fraction, you multiply by the reciprocal of this right here, therefore getting this equation here. Okay, since these two are the same, you can cross those out, therefore it's just 1 times f of x, f of h. Therefore our finished product is this. And this is the answer to C. And we're done with that. Okay, now we're on to the last part of this problem. And here it is asking us to use the definition of a derivative to find f of x in terms of, or f prime of x, find f prime of x in terms of f of x. Okay, here's what we need to start D, part D. This right here, this whole thing right here, is the definition of a derivative, and to find f of x in term, or f prime of x in terms of f of x, we're going to take the limit. And if you remember in part C, the part we just did, that this right here is f of x times f of h, which is what we found, minus f of x. So we can replace this, or we can replace this with this right here. It'll make things easier for taking things out. Okay, now we have a common factor, which is f of x, and we can kind of take out f of x and put it before the limit, because we're talking limit as h approaches 0. So this can sort of be factored out. So now all we have left is this. Now, if you take the limit as h approaches 0 here, you're going to get 0 over 0. And that's not going to work. So therefore we need to take L'Hopital's rule, or yes, that's it. And we have to take the derivative of each of these. So what we're going to have left is f prime of h over 1. So now we have f prime of x equals f of x times f prime of 0, because h is approaching 0 in this. Now, if you remember what we were given in the directions, f prime of 0 equals -1. So this is basically us multiplying by -1. So f prime of 0 equals negative f of x.